Hey, what's up guys? Hope you're doing well. I'm Arvind from PrecisionDataScience. Today we're going to be working on heart disease prediction dataset. We will try to build a machine learning model to predict the heart disease among patients and then deploy the model for demonstration purpose. So without further ado, let's get started. First, we'll be importing warnings to have a cleaner output, and then NumPy and Pandas to work on the array data and data frame. Next, we have Matplotlib and CPON for data visualizations. We will read the Excel file using read_Excel method and assign it to a data frame df. Df info method provides a summary of the data frame. Here we have 303 entries and all are non-null values, which means that there is no missing data. With head and tail method, we can see the top 5 and the bottom 5 rows of the dataset. Here we have columns such as age, which represents the age of the individual in years. Sex indicates the gender of the individual. It's typically encoded in numerical format with 0 indicating female, 1 indicating male. CP represents the chest pain type and categorizes the type of chest pain a person experiences. The value might represent different type of chest pain such as typical angina, atypical angina, non-anginal pain, or asymptomatic. T-rest BPS is resting blood sugar level of the individual measured in milligrams of mercury. It's an indicator of the pressure in the arteries when the heart is at rest between the beats. COL stands for serum cholesterol measurement. It indicates the level of cholesterol in the blood measured in milligrams per deciliter or mgdl. Next we have FPS, which indicates the fasting blood sugar level measured in mgdl. It indicates whether a person's fasting blood sugar level is higher than 120 or not. 1 represents true and 0 represents false. Rest ECG denotes electrocardiographic results while the person is at rest, which helps in diagnosing various heart conditions. THALAC represents the maximum heart rate achieved in beats per minute. Next, EXANG stands for exercise-induced angina. It indicates whether a person experiences angina, chest pain or discomfort during physical activities. 1 equals yes and 0 equals no. Old peak. Old peak represents the ST depression induced by exercise relative to rest. It's a measure of abnormality in the ECG wave, especially at the S and T wave segment, indicating reduced blood flow to the heart muscles. Slope denotes the slope of the peak exercise ST segment. It describes the rate of increase or decrease of the ST segment during exercise. CA represents the number of major blood vessels supplying blood to the heart that are visualized by fluoroscopy. THAL stands for Thallium Stress Test. It's a nuclear imaging test that shows how well the blood flows into the heart muscle, both at rest and during exercise. And at last, we have the target column, which indicates whether a person has heart disease or not. 1 indicates the presence and 0 indicates the absence of the heart disease. Based on the features, we'll try to predict the heart disease. Since there are no missing values, we can check the duplicate values using duplicated method. Keep equals first keeps the first occurrence and drops the other values. After dropping the duplicate values, we can see that there are no duplicates. With NUnique method, we can see the number of unique values in each column, and generally columns with categorical data will have less unique values. Describe method shows the statistics for each columns such as mean, standard deviation, min, max, first, second and third quantiles, that is 25%, 50% and 75%. With value count method applied to the target column, we get to see the distribution of target values among the classes. Here the cases with heart disease class are more than the healthy class. Next, we'll visualize the histogram of each column to see the distribution of data. Here we can see that the classes with numerical data shows a pattern similar to normal distribution and the categorical data are imbalanced among few values. With describe method and percentile from 0.1 to 0.9, we get to see the percentiles from 10 to 90%. We will use this to split the quantiles into 20% and then assign the unique values based on the quantile intervals using cut method. With value counts, we can see that the age has been categorized into 20% intervals. DF info method shows that the age column has categorical data type and we'll convert this column into integer data type using ASType int. We will plot the correlation matrix by considering the decimal float values to 2 decimals. Here the columns are sorted with respect to the target column, and we have positively correlated features like CP, THALAC, slope, etc. and negatively correlated features like Xang, old peak, CA, THAL, etc. In order to make predictions, we have to separate the features and the target column of the dataset. For features, we are considering all the columns except the target column, and for target column, we are considering only the target column. For training the machine learning model, we need to split the data into training and test set. For that, we'll import train test split from the scikit-learn library. We will consider 20% for the test set and 80% for the training set with a random state to maintain consistency. Next, moving on to machine learning model implementation, here we have Random Forest Classifier, where the ensemble of decision trees collaborate through majority voting for robust and accurate predictions. We will instantiate the model with a random shade of 40183 and fit the model for the training data. After the model learns by fitting the data, we're gonna predict the label values for the test set. For evaluation, we're gonna import certain metrics such as accuracy score, classification report, and confusion matrix. Here we have overall accuracy of 87%, and the F1 score varies from 83% for the class 0 to 89% for the class 1. F1 score is basically the harmonic mean of precision and recall. Next, we'll plot the confusion matrix, which shows the correct predictions along the diagonal and wrong predictions as either false positive above the diagonal or false negative below the diagonal. To verify the values, we will do a cross-validation across the dataset using cross-val score from the scikit-learn library. We will apply the cross-validation across the training set with a CV value of 5 folds. After displaying the scores, we can see that the mean value is 81.76% and the values range with a standard deviation of 0.037. This change in the value may be due to small size of the dataset. Now, in order to make improvements to the machine learning model, we'll try to optimize the parameters within the random forest. Here we have created optimized search space which has gone through few iterations. We have used GridSearchCV method for hyperparameter optimizations and we'll try to find the optimized parameter. In the end, we'll print the best parameters and we'll fit the model. After predicting the accuracy in the test set, the accuracy turns out to be 91.8%, which is an improvement of around 5%. And we can also see the improvements in the confusion matrix. Next, we can see the cross-val score has also improved to 83%. And again, the variations are generally due to small size of the dataset. Next, we'll try to make predictions on random data point. With head method, we can see the data for first 5 rows and we'll try to make prediction for the first data point. With random index equal to 1, we'll find the features for the data point and make predictions for the features. After predictions, we can compare the predicted label with the actual label. Here we can see that the predicted label and actual label is 1. Now let's try for a new random index 2. And again we can see that the actual and the predicted label is 0. For model deployment, we'll find the features and the target values for the first data point with location 19. To demonstrate deployment, we'll be using Gradio and create a function to take the feature values to make predictions. We will consider the created function for Gradio interface with input as numbers, output as text box, and title as RTS's prediction. We will launch the demo, and after launching, we'll get a local URL which shows the deployment. You can also try using the notebook interface, but we'll use the link for now. Here, let's enter the feature values for the first data point with location 19, 66, 0, 3, 140, 239, 0, 1, 151, 0, 1.8, 2, 2, 2, and 19. After entering, let's submit, and we can see that the predicted label and actual label is 1. Similarly, let's enter the feature values for second data point with location 280. After entering, we can see that the predicted label and actual label is 0. Like this, you guys can also try replicating the end-to-end project with deployment. So that's all I have today, guys. If you enjoyed this video so far, please like the video, share, subscribe and hit the bell icon to see more content. Thank you.